Alright, so in this video, and in these series of videos, I'm going to talk to you about analyzing functions. And a way to do that is to remember the Big Ten. And no, I'm not talking about the NCAA sports conference. So what the Big Ten is, it's just basically a set of properties that you need to remember for analyzing a function. And they're pretty simple to remember. They're just simple things that you need to look at a function. It's very useful to have a graph handy. So let me explain these 10 little properties that are here. So first is the domain. And the domain is what x that you're allowed to plug into. And the domain is specified as an interval. So usually domains can be, usually you'll see domains as like negative infinity, positive infinity, or sometimes in the case of a rational function, it'll be like if it was y equals 1 over x, negative infinity, 0, u, 0, infinity. Also, you may see something like another interval, maybe like 2, 7. That's not including 7, but it includes 2. Or even 0, positive infinity. These are examples of domains. If you were to say that the function has a domain of all real numbers, you would use this first one, negative infinity to positive infinity, with open parentheses. So that's the domain of a function. Next is the range, and it's just like domain, except you're now looking at y values. What y you're allowed to plug in. So sometimes you may also see it as negative infinity, positive infinity. Also with rational functions, negative infinity 0, and the union with 0 to positive infinity. It works the same as domain. This next one, max and min, it's just saying where the maximum value is and where the minimum value is. And these are specified as points. So for example, in the case of a parabola, if it was y equals x squared, the lowest point, the minimum, would be at the point 0, 0. That's the minimum. If it was y equals minus x squared, it will be that same point, but this time it will be a maximum of 0, 0. If you're going to give maximum and minimum, you have to specify it as a location. Next are the intercepts. The intercepts are where it crosses either the x or y axis. These are also given as locations. So you have to specify points. So for y-intercepts, you're going to have 0, comma, whatever. Let's call that B. And for x-intercepts, you're going to have A, comma, 0. These are specified as locations. X-intercepts are also zeros or roots, which if you haven't watched my videos on finding roots of polynomial functions, go ahead and click the link on the annotation and go ahead and watch that. Now, next is end behavior. And some people kind of get confused on this. End behavior describes how the function behaves as it goes off to negative or positive infinity. And this is used by using limits. So limit notation is a very simple thing. So say our function was y equals 1 over x. Draw a rough sketch here. And so this is y equals 1 over x. And to express end behavior, well, for simplicity, let's call that f of x. So, to express end behavior, what we do is we say that the limit as x approaches infinity, positive infinity in this case, of f of x is equal to, well, what is the value of the function approaching as x gets larger and larger? It approaches 0 in this case, so we say that the limit is 0. It goes for the other direction too. The limit as x approaches negative infinity of f of x is equal to 0. So those are the two things you need for end behavior. You can also have limits that go to infinity as well. Now next is symmetry of a function. And symmetry defines whether it is reflected across the y-axis or if it's symmetric with respect to the origin. So, there are two ways to think about this. If a function is even, then we say that f of minus x is equal to f of x. Some even functions that you may know are y equals x squared, x to the fourth, x to the sixth, and everything with and even multiples as a power. Another even function that you may know is one of the trigonometric functions, the cosine function. And a function is odd. A function is odd if f of minus x is equal to minus f of x. So that's going to be like y equals x, x to the third, to the fifth, odd powers, x raised to any odd powers. And that's symmetry. You will denote if it's even or odd by showing it. Next is continuity. And simply put, you have to define whether or not there is a break in the function. If there's a hole, or if there are any breaks where you can't draw the function in one fell swoop. So you would say, such as infinite discontinuity at x equals whatever. The bounds of a function define if there is a limit on how high or how low it goes. So, for example, for a function like y equals x squared, a parabola, it's bounded below. But for a function like y equals minus x squared, it's bounded above. But for functions like y equals x cubed, they're not bounded at all. They are unbounded. For increasing and decreasing intervals, you define with intervals where the function is increasing, for example, in this y equals x cubed from 0 to infinity, or where it's decreasing, such as here, from 0 to infinity. In asymptotes, you have to define all vertical and horizontal asymptotes of a function, if there are any. You must define them as lines, or if they have slant asymptotes, define them as lines as well. In the next few videos, we're going to analyze some functions.